Good morning. We are Thursday, March 26th, and I realize if you've already done the fourth example for this lesson and you watched me go hit a pop fly and a line drive on our overgrown field, maybe I've lost it. Maybe you've decided, wow, that problem really pushed me over the edge. I now can't possibly love trigonometry, or baseball for that matter. I will employ the help of Angry Birds to change your mind. Could it be said, oh no, could it be said, after all the flying and launch angles and such of a baseball game, that you have to understand to be successful at Angry Birds if you remember such a game? And you say, Mr. Freytet, there's no way I could ever love trigonometry. In fact, I'll love trigonometry when pigs fly. Well, this is your day, because thanks to Angry Birds, we can have a swine and a co-swine. Okay, I make no apologies for that. All right. So we are still solving trig equations, which means I want x by itself. Okay. In this case, here's my function, and I'm only interested in solutions that go between 0 and 2 pi. Now, when they say it like that, when they say 2 pi, are your degrees or radians? Radians. Okay. So just keep that in mind for later. All right. So, well, I'm noticing a couple of things. One thing I'm noticing is I have a squared trig function. What does that make me think? That makes me think Pythagoras. I also have a sine. Oh, wait a minute. Cosine squared. What's cosine squared? Cosine squared can be traded for, let's see, my best Pythagorean identity was cosine squared plus sine squared equals 1. That's the one. So if I subtract sine squared from both sides, it says cosine squared equals 1 minus sine squared. So that's what I'm going to trade for. 1 minus sine squared of x. That 2 is still sitting out there. This sine of x is still sitting here. And thanks to a Pythagorean identity, I now have pure sines. Okay, I still have that quadratic feel to it. Let's distribute and see what happens next. Distribute, distribute, and this is going to come out 2. This is going to come out what? No. Negative 2 sine squared of x minus sine of x minus 1 equals 0. Okay. Ooh, look. These guys can combine so that my new equivalent equation is negative 2 sine squared of x minus sine of x, and together they make a plus 1 equals 0. Hey, that's looking like ax squared plus bx plus c. But I want to leave with a positive. So I'm going to multiply the entire thing by negative 1, which I'm allowed to do. So that's going to come out positive 2 sine squared of x plus sine of x minus 1 equals 0. Oh, I can factor that, can't I? Yes. So, here it goes. In the back of my head, I'm thinking sine is u. This is what I'm thinking in the back. U equals sine of x. Okay? All right, so to have 2 sine squared of x, I would need a 2 times sine of x and a 1 times sine of x. To get a negative 1, I would need a positive 1 and a negative 1. The trick is, how do I get it so that my middle sign, my outside-inside business, comes out with a positive sign? So, if I do it this way, then that's negative 2 sine of x plus 1 negative when. So that's not what I want. I want to switch it. I want to do this way. So that now I can say, right, there's my 2 sine squared first. Here's my outer, that's positive 2 sine of x. Here's my inner, negative 1 sine of x. Combine them, they make my plus 1 sine of x. And then those guys multiply to make negative 1. I am factored. Okay, so now back to our little quadratic trick. If either one of these equals 0, then the whole thing goes to 0 and we're all happy. So I can now say if 2 times the sine of x minus 1 equals 0 and sine of x plus 1 equals 0, those are my 2 situations. I can solve each of them fairly easily. This one's going to go plus 1. And that's now 2 sine of x equals 1. And then divide by 2. Okay. I now know sine of x equals a half. Okay. Over here, subtract 1. And I find out sine of x equals negative 1. Okay, well, I still have to get x by itself. So I could hit arcsine. But wait, this is a half and negative 1. Those fall into some special triangle situations. I don't need my calculator. Besides that, the calculator is only going to give me the first time. Remember, I'm trying to go all the solutions from 0 to 2 pi radians, which means I could get more than one solution. And the graphing calculator won't show me that. So, when is sine a half? Okay, come to my coordinate plane, a half. Let's see, sine is opposite over hypotenuse. So, opposite 1, hypotenuse 2, which triangle is that? That's the 30, 60, 90. So, I need my opposite to be 1 and my hypotenuse to be 2, which means that's rad 3. And let's see, this is a 30, 60, 90 triangle. The shorter side makes this angle 30 degrees. Sweet. Can I say 30 degrees in radians? Well, yes, I can. 30 degrees is, how many 30 degrees are there in 180? 6. So that's pi over 6. Okay. Does this happen again somewhere where sine is a positive 1/2? Well, let's see. I need to keep my vertical component positive, so that means I can draw my triangle over here. And again, here's a 1, here's a 2. This time it's negative rad 3. but I'm interested in sine, so I don't care about the adjacent side. And this is also 30 degrees. Well, that's just the reference angle. What is the full angle that brings me to that point? Well, that would be, if 180 degrees is 6 pi sixths, right? Then this position takes one of those pi sixths away. So that's going to be 5 pi sixths. All right, so there's two of the solutions. Now, here's the other one. When is sine of x equal to -1? Well, if this is my triangle at 0 radians, and my height is 0, my vertical component is 0, then the sine is 0, right? Because opposite over hypotenuse, 0 over 2. So I open my triangle up, it gets to there, and as I keep going, the triangle starts to close until it gets here. And by here, the opposite and the hypotenuse are the same, which means that's where it's 1. I don't want 1, I want -1. Where do you think that is? Well, that's down here, okay? So down here, right, the opposite is the same as the hypotenuse, but negative. So that's where I'm going to get my -1. So what position is that? Well, that is coming all the way around. If that's 6 pi sixths, this would be 12 pi sixths. Halfway between would be 9 pi sixths, which is 3 pi halves when you reduce it. So there are my 3 solutions. And in case you're wondering how to get that on Desmos, I'll show you. Some fancy finger work. And here it comes. All right. So, again, when I get my movie making skills up to snuff, I will be able to show you this. I will be able to put this in the window. Okay, so here's my equation. What I'm going to do is I'm going to put the left side of the equation on my first equation, and then I'll make the right side, which is the 0, my line, my green line. I'm only interested in the zone that exists between 0 and 2 pi. By the way, 2 pi to 3.14 is 6.28. So 2 pi finishes right about here. Okay, so that's 2 pi. What were my 3 solutions? Well, the first one is pi sixths. The second one was 5 pi sixths. And the third one was 3 pi halves. Yeah, now you love trig, don't you?